The Fractal Universe. A 20 by 20 Pecha Kucha presentation by Eric Baird.
Fractals only started to be regarded as a legitimate subject in around 1975. Where normal shapes have detail at a particular scale, fractals have detail across a range of scales, sometimes an infinite range. The red shape is one of the simplest, the Sierpinski triangle. Divide a triangle into 4, throw away the middle, and repeat. Simple rule, infinite detail. Here's another. The bottom right outline is called the cock snowflake. It's normally drawn by taking a triangle, drawing third-size triangles on each side, and repeating, but this version looks more like the Pecha Kucha logo. It has an infinitely crinkly edge. The white squiggle at the bottom is called the cock curve. Fractals can extend into higher dimensions. Bottom right is a cock curve variant extended into 3 dimensions. And top left is a 3-dimensional sponge with an infinite number of holes shaped like cock snowflakes. And here it is for real. Computers can help us to find new fractal shapes. Here's the famous Mandelbrot set. It represents the collision between 2 number systems, a frozen mathematical car crash. It has organic curves and swirls. Its boundary is desperately unstable, and if you zoom in on a region that's almost stable, the leftovers generate a mini Mandelbrot with all the features of the original, and then some. The Mandelbrot is infested with these mini copies that have their own mini copies at the same positions. Studying this thing drives people crazy. The Mandelbrot is only a 2-dimensional slice through a larger 4-dimensional fractal called the Julia set. Here's some other Julia slices at right angles to the Mandelbrot. There's an infinite amount of variation between them, but some common themes across the whole set. Each Julia image is a self-contained universe based on just these 2 fixed numbers. Simple rule, infinite detail. Fractals can emerge spontaneously from packing problems. Forward circles, on the left we pack circles against a wall, and even though the system seems crazy, the points at which each new generation touches the wall divides it into a perfect integer spacings, 2, 3, 4, 5. The thing counts. On the right, filling a golden ratio triangle with squares generates a Fibonacci series and Fibonacci tree. So packing generates both rational and irrational number systems, and sometimes conventional numbers aren't what emerges. Here's the golden ratio again. On the right, a clunky fractal cube packing. On the left is a more organic pattern that you get with golden ratio tetrahedra. Here's another example of an irrational ratio fractal, the Jerusalem cube. Each cube scales to its parent by the ratio 1 plus the square root of 2. The pattern on each face cuts straight through the block. Tiling. Pentangles are full of golden section ratios. Top left is the fractal pentangle Briar, the 5-sided counterpart of the Koch snowflake. And the larger diagram shows how it tiles. The Koch snowflake tiles, too. Plant life and growth patterns. Here's a fractal pattern used by common ferns. Each frond is made of smaller identical copies, which are in turn made of smaller copies still. The shape is built out of itself. The fern fractal works across scales because ferns reproduce using spores. Higher plants have scale-specific optimizations so that they can produce things like seeds and flowers, but after a disaster it's the ferns that recolonize first. This looks like it's computer-generated, but it's real. It's a vegetable called a Romanesque. If you like the patterns on sunflowers, this is the architectural 3D version. Packing creates an initial pattern, and the surrounding pattern then imprints itself on each growing tip. They taste yummy. It's not just plants. Your circulatory system, your nervous system, to some extent your brain, definitely your lungs, are developed and shaped by a set of fractal rules. Your DNA doesn't contain a conventional blueprint, it contains a set of mechanisms and their initial parameters that, recursively applied, just happen to generate you. River systems. The pictures on the right could have been satellite pictures of river formations hundreds or thousands of miles across, but they're only a few inches wide. Like the Mandelbrot set, rivers have 2 opposing needs, to travel in a straight line, and to exaggerate any bends, and that struggle is similar at all scales. The small tributaries have the same distinctive themes as the larger river. Engineering. The fractal approach is useful for building large lightweight structures. We design the shape, then replace it with a framework, and then replace the framework elements with smaller frameworks, and so on. The crane on the left and the main bridge are both based on repeated subdivision. Alexander Graham Bell, kissing his wife Mabel. Mabel liked the idea of aircraft, but they were supposed to be physically impossible. Geometrical scaling problems meant that we weren't even supposed to be able to make large kites. So Bell devised a fractal system that worked the same at all scales, flew giant kites, including one carrying a pilot, and proved that aircraft were possible. Architects often want the style of a building to show in the largest room and the smallest decoration, so they often end up using fractal approaches by default, whether it's in Gothic cathedrals, Cambodian temples, South American step pyramids, or whatever it is that the Brighton Dome is supposed to be. These themes necessarily apply and recur across regions and scales. History repeats itself, but not exactly. There are recurring themes and patterns, so your life is fractal. In 4 dimensions, the tree of decisions that you make, the branching of your body's cells, your family tree, the larger tree of the human population, and the larger phylogenetic tree of all life on Earth, is a 4-dimensional branching structure. Now here's the largest structure in the known universe. This is a map of galaxies, a network of filaments and sheets between a series of empty voids. Time flows faster in the less dense regions, those empty regions expand faster, and matter gets shoved into the cracks between the lobes. Our whole universe may be a single lobe connected to a super-versatile location that gives our fundamental physical constants. And this means that we may be able to understand the universe because our brains and evolved sense of aesthetics may be part of the larger scheme. The universe may be making smaller logical echoes of itself through us. We may be able to understand the themes behind the rules, behind the laws, behind the superverse, behind our universe. We can be its brain, and we can own it. Thank you. Now where's the bar?
Alt Fractals. A visual guide to fractal geometry and design. ISBN 0955 7068 31.